We are still in 1.5, yes. So we'll be in 1.5 next 3 days. So today will actually be the end of new material. And then we're going to spend several days next week reviewing it. We'll play a game over, play a couple games actually. So this is first part's reflections. And that kid looks scary. I don't know if this looks kind of like Chucky before he had the red hair, the scars, maybe. I don't know. I wasn't allowed to watch that movie. I still think I'm 36 years old. I still think my mom would get on to me if I watched it for some reason. I don't know. Okay, so first up we have reflections. Okay. Now remember that my f of x right here is still going to be my parent function. They're erased from the board today. They're not up there. So let's see how well we can remember them. Okay. And so what I'm going to be doing to that parent function is I'm going to be throwing down a negative sign in front of it. Now, would you say that that negative is inside or outside the function? Outside, it is. And yesterday, whenever stuff was outside the function, we added and subtracted numbers yesterday from the function. Did it move it left and right or up and down? Up and down. Good news. Today, every time there's a negative outside the function, I'm multiplying by negative something, it is going to move it up and down. What does that look like? Looks like this blue line right here. It's just something from your homework. That was like that 2 to the x that you did, or that you are going to do this weekend. And so what happens is if I throw a negative on the outside, it just reflects down over this x-axis to this green line. Okay? So it's just like it's looking in the mirror, or a puddle, or a lake, or something that sees itself. Where does it see itself? Down here in the ground. Okay? So this is a vertical reflection. You're going to hear me say over the x-axis. What? Horizontal. All right. So let's go down here to this g of f of negative x. This negative is inside the function. Yesterday, whenever I was adding and subtracting numbers that were inside the function, which way did they move? Right and left. Good news. The reflection is going to be a horizontal reflection. It's going to move right and left about the x-axis, or over the x-axis. So this blue line, if I was to throw a negative on the inside of the function, like I've done here, what happens is this top of the line sees itself in a mirror over here, just a mirror reflection, and in the bottom of the line sees itself in a mirror reflection on this side. Okay. We'll get a lot of practice with that today. I don't think this will be a problem. So I'm going to make up a function right here. Not make one up. I'm just going to pick one of the parent functions that describes well what we are doing. So I'm going to choose the square root of x. What did the square root of x look like? Ooh, parabola or swoop? The swoop. Okay, the swoop. Yeah, that's getting too detailed. All right, so if I was to reflect this vertically, it's going to come down underneath the axis. Just looking at stuff. What I want to know is, I'm going to call this g of x. What does my function look like? Just throwing a negative somewhere. Negative square root of x. I'm going to put the negative on the outside because I reflected this up and down. Does that make sense? So what if I take my red swoop and I reflect it over the y-axis? I'm going to call this h of x. What is it? Square root of a negative x. Sorry, that green's tough to see. It says square root of negative x. Okay. So part of your homework tonight is going to want you to write a function for the graphed function. All right. see how hard I can make this. Should I start off easy on you guys? I won't hurt you too hard. Not this one. All right, what is my parent function on this one? Absolute value. So I'm going to put f of x equals absolute value of x. Now I'm going to leave a lot of space around it because I'm not sure where I need negatives, if I'm going to be adding or subtracting numbers. Let's do all the horizontal stuff first. Did this thing move left or right? It moved to the right. How do I show in my function that it moved to the right? Minus 3, plus 3. Minus 3, it's opposite. Everything on the inside is opposite. So since I came over here to 3, I'm actually going to have a minus 3. Is that all I did? I reflected it over the x-axis. So where's the negative go? Okay, it goes outside the function. In this case, that's outside the absolute value. So I throw a negative right here. And that would be the graph of it. Oh yeah, he's coming soon. All right, I want to do one more. Back to the swoop. Plus square root of x. What all happened to the swoop? It what? 180 degrees. I rotated it. How do I rotate something 180 degrees? Reflect it twice. Not only, here's my original swoop right here. I reflected it over the y-axis, which puts a negative where? Inside the function. And then I reflect it again down here. That rotates it 180 degrees. And then, so whenever I reflect it down, it puts the negative on the outside. But I moved it down one. So where do I put that 1 at? Plus 1? Yeah, it goes outside because it's vertical, right? And everything outside makes sense. So it comes down 1. Good. All right, we'll do some more of those in a minute. I'm going to add in a little bit of extra fun. Oh, you just wait. Grace. It is not. It is on the outside since it came down. If it went right or left, I would have extended that square root. All right. Now I'm going to put a video in for next year. You guys all saw the video, I guess, except for Alyssa. Oh, Demi didn't see it either. Afterwards, I'll show it afterwards. Since we're recording right now, it makes it so I have to save it as a different file type, and I'm not sure what YouTube's going to do with it. But yeah, Richard Simmons, he's good at what? Dancing. As he's working out, he's stretching, right? And so we'll find that video so Demi and Alyssa can see that, okay? So what we're going to be doing with these functions is we're going to be stretching them just like Richard Simmons stretched out middle-aged women in the late 80s as far as aerobically. I don't know why I put that on there. Anyway, and we're also going to be condensing or compressing, all right? Just pushing down on the functions like this guy is pushing down on himself, 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 and himself, and probably more so, okay? Now, I just want to do vertical first. So on a vertical, remember, this f of x right here stands for my parent function. So we're not always going to be given a parent function, but for the most part, they will be a parent function. But I want us used to seeing both. So I'm going to have g of x equals a f of x. Is that a, is it inside or outside? Outside the function, which is good because this whole slide is dealing with vertical stretches and compressions. Now I thought we threw numbers on the outside yesterday. So how's this different? Oh, we're multiplying on the outside. That's what's going to stretch it. That's what's going to compress it. Now, everything yesterday, whenever it moved up and down, just like on the last slide, it made sense. Okay? So luckily for us, if A is greater than 1, what I'm going to do is I'm going to take the graph, I'm going to stretch it vertically. I'm going to pull up on the top of it, pull it away from the axis. It's going to be a stretch. Whereas if A is between 0 and 1, let's just say 1/2. We're just going to take our foot and we're going to squish it onto the x-axis. Okay? So it's going to be compressed. Or you can call it squished, I don't care. This confuses a lot of people, so I went ahead and put this on this slide. If A is less than 0, if A is less than 0, we are talking about having to do a reflection and then come up here and either do a stretch or compression. So you're going to see me treat it as two different transformations. Questions on that? Okay, at least get that written down. It's in your slides, so you can have it. I think it'll make sense before we get started on homework. So just as a visual picture for you, I know this graph might not look familiar when you, or if you take stats with me either this year or next year, you will see something that looks very similar to this, okay? And so this blue line right here is my parent function. Now I just want to show you just the physical movement that we're doing on this. If I'm wanting to do a vertical stretch, it's like I'm hanging on to it on the axis, but I'm just making it so it's taller, okay? Changes the shape of it a little bit, looks a little bit skinnier, but it's also taller. Whereas if A is between 0 and 1, like this 1/2 right here, it's like I'm stepping on it, making it smaller and go down, okay? So that's what I want to do with some of these graphs. Let's do it to this line graph. I apologize, I should have printed this off, but if you want to, you can just do a rough sketch of this. But this is the amount of rain Dexter received during the first 9 days of April. Okay, St. Louis only got half as much rain each day. So sketch a graph of St. Louis's rainfall during this period. So let's just let this red line up here be f of x. That's the amount of rain Dexter received. And what I'm going to do is I'm going to put another line underneath it, g of x. That'll be St. Louis's rainfall. And so we know in order to get it, I'm just going to have to just come through and manually just take the 5 and then take half of it, knock it down to 2.5. I'm taking all these y values or all these f of x values and multiplying them by 1/2. So the 2 becomes a 1. 12 becomes a 6. 7, a 3.5. There, 1.5. Here, and then 1, and then 1, 2, 3. So if they got exactly as much rain, I would go through, connect these dots. It would look like this. What I'm really wanting you to see on this graph is that I took this red line and I'm just stepping on it and compressing it down by 1/2. Okay? We're flying through these. Most of your homework tonight is just going to want you to describe transformations. And that will get us ready for activity on Monday when we come in. And so they're not even going to give you a parent function. They're just going to leave it generic f of x, okay? But they're going to throw in a number. Say, suppose I do this, 2 times f of x, okay? And I'm going to put one of these on your quiz and or test next week. And I'm going to say, describe the transformations that's going on to f of x. And on this one, you would say what? They stretched by 2. I'm more interested in you telling me which direction it's going to be stretched, because we're about to add some more to that. Stretched vertically by 2. Good. stretched vertically. I like putting in there by 2. Okay, good. All right. Let's do this one. Keep putting in extra parentheses. It'll be okay. I'm actually gonna take it out. Stop doing it here in a minute. F of x. Good. All right. So negative 1/3 f of x. Vertical compression. It's a mixture. Oh, so what else am I doing? Reflecting across the x-axis. So I have to treat this negative and the 1/3 as 2 different transformations. So vertical compression and reflected over the x-axis. You can't. I'm more interested in just saying vertical compression right now, because I'm really not even going to grade. We're going to talk about that in a minute. I'm not even going to grade the 1/3, but yeah, vertical compression by 1/3. So it's going to be 1/3 as tall, but I'm really interested in seeing these words right there. All right. So yeah, I think that's good. It's good because we have to do horizontal compressions as well and stretches. Okay, so for a horizontal stretch or compression, we're going to see, again, multiplying, but just like horizontal was inside yesterday, this b is going to be multiplying on the inside of my function. Now, yesterday, everything was backwards, right? So if I had +3, I moved it to the left, and if I had -3, I had to move it to the right. Everything's going to stay backwards on this as well. For instance, if this b right here is greater than 1, a while ago when b was greater than 1, suppose it was 2, we stretched it by a factor of 2, correct? Well, if it's on the inside, it's opposite. It's actually going to compress it by 1/2. It's going to be half as wide. So I call it compressed by the reciprocal of b. So let's just suppose b is 2. If b is 2, I'm going to compress it by how much? 1/2, the reciprocal of 2. Does that make sense? It's all backwards on the inside. So a while ago, whenever I multiplied something between 0 and 1, I compressed it by 1/3. Well, now that it's on the inside, it's the opposite. It's going to stretch by the reciprocal of b. So if b is 1/3, I'm going to stretch it by how much horizontally? By how much? I'm going to stretch it by 3, just the reciprocal. Okay. And then finally, do not forget, same bottom line here. If it's less than 0, it's a reflection. We're going to treat it as 2 separate transformations. We're going to do a reflection, and then we're going to do either a compression or stretch, depending on whether it's greater than or less than 1. Okay? Most of the time it won't matter, but we will go over that before the end, okay? The order in which we want to do things. So which one of my functions is this? The blue one. Parabola, which is the what? X squared term. So this blue function right here is f of x equals x squared. Now I'm not going to ask this on the quiz, the test, and I'll kind of go into detail with this. This is a question I had earlier, and it was a great question. But like this g of x right here, yeah, I'll do the g of x first. I'm taking this blue line and I'm pulling it away, right? It's a horizontal stretch by, let's just call it 2. So if I horizontally stretch this by 2, where do I put that 2 at? I still have the x squared, right? So Bree says I throw a 1/2 where? Put it in front. Parentheses around what? Exactly right. All right, just the 1/2 x. All right. Just the 1/2 x. Doesn't that look weird? What if I was to take off this parenthesis? I get 1/4 x squared, right? And the 1/4 would be on the outside. Doesn't this green line kind of look like I squished the blue line vertically by 1/4? It looks the exact same. That's why I'm not going to be asking you to write a formula for this unless I put arrows on it. Okay. So let's do the h of x, the red line. H of x, I took the graph and I compressed it. I pushed it towards the axis. Let's just say by a factor of 2, like it says up here. So I still have my x squared. What do I need to put in to there? Where's the 2 go? Goes in front. So it's just 2x squared. Again, I need it parentheses because it's moving horizontally. That's really confusing with what we've done earlier in this lecture, all right? Because it also looks like maybe I just took this red line and I made it taller. It became skinnier, right? So how do we know which way it goes? They do look the same, okay? And for what we're going to be doing in here, they are the same. So same idea. So you are right in thinking that it does look the same because it is going to be the same. Okay, let's describe a couple more functions, and then I'll have you guys make some up. Let's do f of 2x minus 1. F of 2x minus 1. I would start on the inside and work our way out. Okay, so what's being done on the inside of this function right there? What's that 2 doing to it? Horizontal compression, okay? It's on the inside, so it's horizontal. Horizontal, and then you would think stretched by 2 because you're multiplying it by 2, so it would make it bigger, but it's opposite. It's a horizontal compression. Or squish, or whatever you want to call it. Is that it? What's that minus 1 doing? Is that reflecting it? It's moving down 1. I'm subtracting 1, so it's going down 1 unit. Okay. For what we're going to do in here, we won't have a lot that's has a horizontal compression and a horizontal shift, because I'm going to talk about that a little bit on Tuesday, but for right now, I don't foresee us having a whole lot like that. All right, let's do f of negative 1/4 x. F of negative 1/4 x times 2. Let's do it times 2. Again, let's start on the inside. What's something you see on the inside, Parker? Negative 1/4. We need to break that apart. You want to do the negative, you want to do the 1/4? Let's do the negative. Okay, the negative's on the inside, so which way is this going to be reflected? It's going to be reflected horizontally, left and right, over the y-axis. So we could say reflected over y-axis. Good. Okay, so I did the negative. I'm going to do the 1/4 now. What's that 1/4 going to do? Stretch it. Which way? That's fine. Just like that will be fine. Stretch horizontally. Right, finally get that 2 in front. What's that 2 going to do? It's going to be a stretch vertically as well. I'm going to stretch it 4 times as wide as it is, and then once it gets that wide, I'm going to make it so it's twice as tall. So I would also stretch it vertically. Stretch vertically. All right, let's see what all this looks like with our parent functions. Okay, it's time to get out of here. Okay. All right, Jaden, give me one of my 7 basic parent functions we went over. X cubed. Ooh, X cubed. Did a really good X cubed one last time. I don't remember what it was. This one will work. Let's change it a little bit. I want to do this. There we go. I like that better. So first off, we have to figure out, what does X cubed look like? Snake on a plane, right? Snake on a plane. So I'm going to go ahead and draw my parent function. You'll kind of have a better appreciation as to why I'm drawing this parent function here in just a little bit. Now I want to start on the inside. Okay, I look inside parentheses, inside the function right here, and I have a -1. What is that doing to my snake? It moves everything to the right one. You guys agree? So now my snake is over here. From here, I start working away from the X. Okay, so next step, I'm gonna deal with this 2 right here. What's that 2 doing to this snake on a plane? Vertical stretch. It's outside the function, so it's vertical. It makes sense. It's got to be twice as big. So I'm going to take this snake right here, and I'm going to pull on it so it's twice as big. It's got to make it so it's skinnier. Maybe I should switch colors on that. Kind of a hard one to stretch. So I took this black line, I made it so it's stretched out a little bit. Okay. And then finally that negative. Reflect over the X. There's a lot of stuff going on. So we're just taking it a piece at a time. So reflecting it over the x-axis is going to make it so this part of the snake comes down, and this one goes up. So there we go. I want to see a stretched out snake move to the right one that's been turned around. We're going to do a lot more practice with this next week. All right. So but for now, I just want to get you used to seeing it a little bit. All right. Let's do one more. Grace, give me a parent function. Don't make it so it's x cubed, and don't do the constant or identity function. Cube root. Oh. Cube root. All right. Okay. Let's do. I wish I would have done some of the last ones with this cube root. I'll just leave this one pretty basic. We might do an extra one. What does my cube root function look like? All right. The sleeping snake on a plane. Starting on the inside, what's that negative going to do? Flip it over the x-axis? The y-axis? Does it matter? Does it? Flip it over the x-axis in your mind. Now flip it over the y-axis. Okay, it matters to Audrey. But everyone else, good news. If we're dealing with x cubed or the cube root of x, and you just have to do one reflection, it doesn't really matter which way you reflect it. Okay, so yeah, I've just got to reflect it. So it actually gets reflected over the y-axis in this case. So now the snake is coming back this way. Something like that. And then what's that plus 2 going to do to my snake? It moves it up 2. So I'm going to come up 2. Draw. Kind of missed my points there. Opa. And that would be my answer. All right, Annie, give me one more. Ooh, you want to do a parabola? All right. X squared. Let's do 1/3. Do negative 1/3. X minus 1 squared. How many transformations do I have going on in this one? 4. 3. Well, the good news, no one said 2. I was afraid someone was going to say 2. If you're thinking 4, maybe you got a bonus one. I don't see. I'm thinking 3 on this one. Okay. So I've got my u right here. Start on the inside. Just a general rule. Start on the inside on these functions. What's that minus 1 going to do? Right one. I think I just did that one. Sorry for the redundancy. So the u moved to the right one. Now, starting with, I want to start moving away from the x, so that 1/3's up next. What's that 1/3 going to do? Compresses it. Which way? Down or vertically? Yeah, it's like I'm taking my foot and I'm stepping on top of this parabola. So what happens to it? It gets squished. I am not pulling out a ruler to make sure it's been compressed by a factor of 1/3. If I see that you have a flatter parabola, that's good. But see how I can kind of follow your work as to what you did? And then finally, that negative. It's gonna take this flattened parabola and it's gonna reflect it over the x-axis. This would be full credit. Okay. What I really like to see is this original parent function right here, and I can tell that you flattened it by the time you got down to here. So it's a lot easier for me to tell that you knew all the transformations, that you knew what was going on.